Your MCP client needs to launch a FastMCP server, but you don't want to manually construct the command every time. We'll see how FastMCP2 generates a standardized mcpServers JSON configuration that works across all MCP-compatible clients. The configuration includes the UV process runner with the exact arguments needed to start your server, using absolute paths for reliability. This same format can be generated with FastMCP install MCP JSON and supports optional environment variables through the env field, ensuring your server starts correctly whether using SDDO or HTTP transport.
My server. Command UV. Args. Run. With FastMCP. FastMCP. Run. /absolute/path/to/server. Hi.
This demonstrates the standardized MCP JSON configuration pattern for server deployment. The declarative format encapsulates all runtime requirements, executable command, arguments, and optional environment variables in a portable structure that works across MCP-compatible clients. The key distinction is its dual role as both a deployment specification and a client integration contract, ensuring consistent server behavior regardless of the launching environment. The configuration follows a hierarchical structure where the command field specifies the process runner, UV, while args define the complete execution chain, including FastMCP protocol activation and server entry point. The use of absolute paths guarantees reliable server startup even when clients execute from different working directories, and the optional env field handles environment-specific variables without code changes. This separation allows the same server code to run in development, production, or CI environments simply by varying the configuration. This pattern solves the challenge of cross-client compatibility in AI workflow systems. By adopting this standard format, servers become immediately usable in Claude Desktop, VS Code, Cursor, and other MCP clients without custom integration code. The trade-off is the initial configuration overhead, but the benefit is significant. Teams can version control deployment specifications alongside code, enabling reproducible setups and simplifying environment management across complex toolchains. Let's break it down line by line. This defines a FastMCP server configuration in JSON format, typically used in a client's mcpServers object. The structure follows the standard generated by FastMCP inspect and supports both SDDO and HTTP transports. The command field specifies UV as the modern Python process runner, with run being of standard command execution mode. The with FastMCP argument enables FastMCP's protocol layer, while the second, run argument and absolute path point to your server's entry point, ensuring reliable startup even in isolated environments created by FastMCP install. This same configuration works with FastMCP install MCP JSON for advanced deployment scenarios.
My server.
Defines a server profile in FastMCP's standard configuration format. This key creates a named entry in the client's mcpServers object, with UV as the modern Python process runner handling execution. The args array follows of's command structure, where the first run is UV specific, while the second triggers your server's main entry point. The absolute path ensures reliable startup across isolated environments, including FastMCP's install commands. This same configuration works with both SDDO and HTTP transports and can be auto-generated using FastMCP inspect or managed via FastMCP install MCP JSON.
Command UV.
Specifies UV as the process runner, the modern Python execution engine that replaces Python M with better performance and reliability. This configuration follows FastMCP's standard server definition format, typically used in a client's MCP servers, object or generated via FastMCP inspect. The format supports optional env fields for environment variables and works consistently across both SDDO and HTTP transports. Absolute paths ensure compatibility with FastMCP's isolated execution environments during FastMCP install operations.
args,
The args array defines the complete command line invocation for the server process. This follows of's execution model, where the first run is of's subcommand, while the second run plus the absolute path form the actual application command. The configuration typically lives in a client's mcpServers object, with the absolute path ensuring reliable execution even in isolated environments. While this example shows SDDO transport, the same structure works with HTTP transport and can be generated or installed using FastMCP inspect or FastMCP install MCP JSON.
run,
This is the UV process runner's command argument, part of the modern Python execution stack. It tells UV to execute the subsequent command with optimized resource handling, replacing older patterns like Python M. The second run argument here is FastMCP specific. It instructs the FastMCP runtime to start your server's main entry point, server, hi. This configuration is typically embedded in a client's mcpServers object, ensuring consistent server management across MCP-compatible tools. The absolute path guarantees reliable execution, even in isolated environments created by FastMCP install.
with,
The with flag activates FastMCP's plugin system within UV, the modern Python process runner. It loads the FastMCP plugin before execution, enabling protocol support, async tool registration, and transport handling, critical for MCP-compatible clients. This configuration typically lives in a client's mcpServers object and mirrors the structure generated by FastMCP inspect. The full args array follows of's command syntax. UV run with plugin run module. The absolute path ensures reliable execution in isolated environments, while the same format works across SDDO and HTTP transports. For advanced cases, you can extend this with an env field for environment variables or use it with FastMCP install MCP JSON.
FastMCP,
The first run is of's command to execute a Python module, while the FastMCP argument enables FastMCP's protocol layer for AI tool execution. This configuration typically lives in a client's mcpServers object and can be generated via FastMCP inspect. The absolute path ensures reliable server startup, even in isolated environments created by FastMCP install commands. The same format works for both SDDO and HTTP transports and supports an optional env field for environment variables.
FastMCP,
This is the FastMCP server configuration in MCP's standard JSON format, typically used in a client's mcpServers object. The UV process runner executes the server with FastMCP protocol support via the with FastMCP flag, while the absolute path ensures reliable startup in isolated environments. The first run is of's command structure. The second invokes your server's entry point. This same configuration works with both SDDO and HTTP transports and can be generated via FastMCP inspect or used with FastMCP install MCP JSON for advanced deployments. Optional env fields can specify environment variables as shown in official documentation.
run,
This is the first part of OV's command structure, telling the process runner to execute the following arguments. The UV tool serves as a modern Python process manager, replacing older patterns like Python M. The second run argument here is FastMCP specific, instructing the server to start processing requests and initialize all registered tools. This configuration typically lives in the client's mcpServers object, and the same format works for both SDDO and HTTP transports. The absolute path ensures reliable execution even in isolated environments created by FastMCP install commands.
/absolute/path/to/server. Hi.
Absolute file system, path to your server's main module. FastMCP requires this for reliable startup, especially in isolated environments created by FastMCP install commands. The path ensures compatibility across different transport layers and deployment scenarios, whether using SDDO or HTTP protocols. Terminates the arguments array for the UV run command configuration. This closing bracket finalizes the complete server execution specification, which typically resides in a client's mcpServers object. The structure follows FastMCP's standard configuration format, compatible with both SDDO and HTTP transports, and is often generated via FastMCP inspect for consistency. This closing brace completes the server configuration object in FastMCP's standard JSON format. It defines a runnable server instance that clients can connect to, typically loaded into the client's mcpServers object. The structure follows FastMCP's inspect-generated configuration pattern, compatible with both SDDO and HTTP transports. The same format works with FastMCP install MCP JSON for advanced deployment scenarios, while the absolute path ensures reliable execution in isolated environments. Closing brace completes the server configuration object in MCP's standard JSON format. This structure defines executable servers for MCP-compatible clients, typically loaded via the client's mcpServers configuration field. The format matches what FastMCP inspect generates and works with both SDDO and HTTP transports. It's also compatible with FastMCP install MCP JSON for advanced deployment scenarios. FastMCP server configuration. This JSON structure defines how MCP-compatible clients execute your server, specifying the process runner, UV protocol activation with FastMCP, and absolute entry point path for reliable execution across environments. The args array follows UV's command syntax precisely, where the first run belongs to UV's execution model, while the second invokes FastMCP's runtime, both required for proper protocol initialization. Environment variables must be explicitly declared in the optional env field, as FastMCP servers run in isolated contexts without shell inheritance.
The configuration that names the server becomes the silent contract between runner and client.